Right, so adding these two together. Now the first thing that I ask myself when I'm adding or subtracting surds is, are they simplified? And the answer this time is no, they're not. Knowing times tables well, if you do, you'll be able to see that this one can be broken up into 9 times 2. So let's start with this one. 9 times 2. Now as soon as we've got that perfect square there, we can proceed with our splitting of the surd. There, that becomes 3 times root 2, and that becomes 3 root 2, like that. Now this one over here, root 8, is obviously 4 times 2. And again, once we've got that, it's just a matter of splitting it up into the root 4 times the root 2, there, and that becomes 2 times root 2, which becomes 2 root 2. Now there's a plus in the middle here, all the way down. We haven't used that yet. We can use that now. 3 lots of root 2 plus 2 root 2 is 5 root 2. There. Now, if we were to go back and put this as a complete surd, I think we're in for a bit of a surprise. Now, we've already seen that this equals 5 root 2 here. Let's see what that equals as a completed surd. This one becomes 25, square root of 25 times root 2, which becomes the square root of 50. How about that? So the square root of 18 plus the square root of 8 equals the square root of 50. Let's have another one. Okay, let's see what we can do with this one. Now, 12, we're going to simplify that first. That becomes the square root of 4 times 3, which becomes the square root of 4 times the square root of 3, which becomes 2 times root 3, which is 2 root 3. Now, 75. Got to be on your toes with this one a little bit. That's 25 times 3. Now that becomes the square root of 25 times the root of 3, which becomes 5 times root 3, which is 5 root 3. And of course, they're all positive. There, plus signs. All right. Now here, these have got some minuses here. Let's do the last one. We can see that in 32, the highest perfect square we can find in there is 16, and that becomes 16 times 2. So that becomes root 16 times root 2, which becomes 4 times root 2, which becomes 4 root 2. Now, let's have a further look at the answer here. I've got 2 lots of root 3 here, plus another 5 lots of root 3 here, becomes 7 root 3. And then here I've got minus 4 lots of root 2, and there aren't any other lots of root 2. So it's just minus 4 root 2. And so that is the answer to this problem.